Customers will often ask how to analyze contaminants in their samples. You may think of contaminants as falling into one of two categories. In one category, this sample material is contaminated by a small amount of foreign material, which is then diluted through the entire body of sample material. This dilution causes that contaminant to be present at some low concentration throughout the entire body of material. In the other category, we can think of the contaminant as being a particle which falls in and remains a discrete body of foreign material. In this instance, because of its small size, or in other instances where the region of interest on a sample is extremely small, infrared microscopy is often employed for sake of the analysis. Infrared microscopes have the ability to focus the infrared beam and perform infrared measurements such as those performed with a typical FTIR, except on a much smaller scale. Also, oftentimes automation is employed in the stage or in the software, which allows the system to measure multiple regions of interest, up to and including a full image in the infrared spectral range of the sample material. Here we have the Spotlight 400 system. This infrared microscope takes the infrared beam from the FTIR on the right-hand side. The infrared beam comes in and it is reflected by a series of optics within the base of the microscope. Those optics will allow the infrared beam to go to the lower objective, where that infrared beam is then focused on the sample, which is placed in the sample stage here in the microscope. Once the infrared light has interacted with the sample, the light goes to the upper objective and is then passed to the infrared detector. These microscopes also employ a CCD camera, which is able to view the sample. This allows you to identify a region of interest on a sample using visible features, as well as with the Spotlight 400, having the ability to measure a full infrared image to identify regions of interest. These infrared microscopes will often employ what is referred to as an MCT detector. The infrared beam is focused to perform measurements of that sample and that region of interest. If that region of interest is extremely small, apertures are employed to restrict the infrared beam which travels through the sample to the detector. Because apertures are employed, a small amount of light is actually able to reach the detector. It's important that the apertures are there to allow measurement of a targeted region of the sample, but then the MCT detector is required for its high sensitivity. It can work with very small amounts of light, which makes it extremely helpful in microscopic measurements.